Hello, good evening, good afternoon, everybody. Today I'm excited to reconnect for Technology in Renewables, a series we ran some time ago. And in today's sessions, we are joined by Conrad Eustis, one of the foundational voices in energy technology and the long-time thought leader at Portland General Electric. With a PhD in engineering and public policy, Conrad's career has spent over 4 decades focusing on advanced technologies for sustainable energy delivery. Conrad, really great to have you here. I know you've got some introduction. Feel free, obviously, to share more about your journey. Today, we're going to be talking about CTA 2045 and the future of grid integrated devices with you. So good to have you here and welcome.
Thank you, Bart. I'm glad to be here. I'm happy to share my thoughts on what I think is a very important technology in the interest of sustainable energy. As you mentioned, I've been in the industry a long time, pretty much doing energy almost 50 years now. I started with a course my senior year. I didn't know that was going to turn into anything major, but after college, I went into the nuclear navy. Got to play around with submarines, nuclear reactors. That was exciting. And but ultimately, I wasn't really personality-wise compatible with the Navy. So I got out and went to grad school at Carnegie Mellon, as you mentioned, and got a master's in mechanical engineering as I went along the way to validate the thermodynamics and heat transfer that I had learned in the Navy. And then in '86, I started at Portland General Electric, and I had an incredible opportunity there. Pretty much my entire career, I got to work on projects that were new to Portland General Electric. Um, I did our company's first demand side resource plan. I did industrial cogeneration. But then I started with demand response in '93 and spent a lot of time with smart meters along the way. So that I got very involved with communication.
Yeah, well, so
Uh,
so it's amazing your career started at General Portland Electric started at 86. What was the time again that you started the demand response programs and working on those over there?
well, so it was in 1993. Back then, uh, there was no internet. It was called the Information Superhighway.
Yeah.
And there was a vice president at another utility in Southeast United States called Entergy. And he testified in Congress that he could build the information superhighway on the back of demand response because of the benefit of demand response. And he was working with like a spinoff company from a Southern Bell um, telephone company. And that project ultimately totally failed, as did many other projects along the way, but all valuable in um, learning about communication and what works ultimately with customers. And so my whole experience has to do with customers and really mass market devices for the last 30 years of my career.
Well, that's amazing. And can you tell us, what was the so demand response again, 1993, and ever are still talking about the demand response, today. So how do you perceive like the demand response, effectively 40, 50 years ago, 30, 40 years ago, comparing to today?
So, I mean, it started back sort of simultaneous with the Three Mile Island catastrophe in the US. And uh, at that time, inflation went through the roof, much higher than it is today. And there were, I don't know, dozens of nuclear power plants under construction. And it affected their costs incredibly on many accounts. But one was the delayed construction because of Three Mile Island. Then it was a 10-year project. The high interest rates meant the carrying costs were tremendous. And the plants came on at 10 times their normal expected price. So as a result, the regulator said, well, we need something that looks at other opportunities besides just power plants. And demand response, the idea is um, you can avoid building peaking plants, the type that are used when it's very cold or very hot to meet peak demand. And so it pretty much started in the 80s. Today, it's still used for peak load management, but it's
Hmm.
increasingly going to be used as a flexible resource to help integrate wind and renewables. The timing of when you have excess renewables or when you don't have any renewables is going to be very important in a sustainable grid with 100% renewables. And so you might use flexible, they're now called flexible resources that can use more energy when there's plenty of excess and less energy when there isn't wind or sun available.
Well, everything what you just said is basically also connected with well, grid connected devices, and I'm just swiftly trying to move forward to the core of our discussion today. CTA 2045, a protocol that is proving a session for the grid connected devices and demand response solutions. So, can you tell us a little bit more in terms of like what is CTA 2045 and what role does it play in the energy sector?
So it's also known as the EcoPort. It got recently trademarked 2 or 3 years ago, and it's a socket very much like USB. But the difference is it's engineered into the mass market appliance. So a water heater, a pool pump controller, an EV charger, thermostat. Um, and it allows, once a communication device is plugged in, it allows remote operation of that appliance by the utility or the customer. And by remote operation, I don't mean it really changes the behavior of the appliance. It really informs the appliance about opportunities to use more or less energy so as to help the grid. So it allows it to be a
Hmm.
beneficial partner in the grid instead of just doing only what the customer wants. But the customer needs are always put first. So it isn't like it's annoying the customer. In fact, it should be totally invisible.
Hmm.
Um, it also can reduce the carbon footprint of the appliance because if it can shift energy to when there's more wind or solar energy, as opposed to when there's more fossil fuel plants, then it reduces the carbon footprint. Um, but as I said, it doesn't actually create this benefit until the customer plugs in the communication device.
Hmm. So is this the way that basically this CTA 2045, as you mentioned, trademark as an EcoPort recently, improve the communication and interoperability between energy devices and the grid? And by energy devices, you mean the customer devices, right?
I say that the what type of devices?
The customer devices, right?
Yes, the customer devices. Generally speaking, large loads, not the stove because there's stoves aren't really used that much except when it's really important. So, but definitely it could be a water heater. It has natural thermal storage. Could be the HVAC system through using thermal storage of the house. It could be a pool pump, which is very flexible when it runs. It could be actually, if it gets cheap enough, a refrigerator. Uh, for example, the defrost cycle runs randomly now, but it could be coincident when excess energy. It's got to be cheaper and more. It's got to be scaled before it could reach that. But other devices, perhaps even like an electric dryer, could delay the start to a time when there's more sun or more wind. So, but the low hanging fruit is going to be HVAC and water heaters.
Hmm.
EVs is another huge opportunity, but that's a market that's got a lot of competition for other standards.
Yeah, OCPP being one of it.
Just one of many.
Yeah, just one of many. Obviously, IEEE 2030.5 as well. But focusing on the long-hanging fruit, as you just mentioned, the HVACs and water heaters. So, how the EcoPort should be applicable? Like, can any device just use it? Like, how the device can be EcoPort friendly or ready to be onboarded for this standard.
Um, so it has to be engineered into the appliance. Uh, so back to my original demand response efforts. Um, they even the ones after 93, the early ones in 94, 95, all failed for a couple, two major reasons. One is it's very hard to recruit customers when you have to tell them we're going to come into your home and we're going to install a box on something and we're going to remote control it. And it's just a very unfriendly
Yeah,
customer
and
experience.
everybody are freaking out in terms of losing control
Right.
and being
It
dependent.
just, it's, and even more so. So that was in the uh, mid 90s when people were actually much more cooperative with utilities, and the concept of apps and smart things was foreign to everybody. So today it's just, it's like you get a blank stare or a what, or. So the idea, so all of that cost, the scheduling, you had to spend a technician to install it, was very expensive. And the labor component to do that approach has even gotten worse today. Um, and the hardware is specialized and works independently of the appliance. So it's sort of like I call it the crowbar approach. It just turns it off or turns it on, and there's no smarts involved. So the idea started uh, actually for me in 2005 when I was very involved with smart meters. And there was a meeting in California where everybody was talking about how it was a big thing in California at the time that the smart meter would be the center of demand response and able to reach out to all the appliances. And I got very frustrated with that because, as I knew, the cost isn't the controller. I'd been in so many pilots where everybody wants to be the center of the universe where all the commands come in, the controller or the gateway. And it totally disregards the fact that the cost is all involved in getting to the appliance, the last, 100 feet, so to speak, or 50 feet. And so
Hmm.
the idea was a socket on the appliance that could be compatible with any communication device. Could be the smart meters, but it could be outside the home as well. And then in 2006 and 7, I started to work with Pacific Northwest Laboratory. It's an energy lab in the Pacific Northwest. And they were working on a project, not exactly demand response, but something to control frequency. But it was an opportunity to work on demand response. And at the end of that project, I was able to write sort of a side paragraph on how a socket would enable what they were trying to do, as well as demand response. And then we did a paper with the same group that showed how much potential there was compared to what we have today. And but it really took off the development of the socket in 2008 through 2012. I kept pushing the idea, and I got support from Electric Power Research Institute, EPRI. I got support from what had just been formed at the time called the Smart Grid Interoperability Panel, which was a government effort to get all the stakeholders to try and improve all things grid related, trying to enable the smart grid. And ultimately, as all that effort, with dozens of people involved in the standard, it got published in the Consumer Technology Association in 2013. But it was just a standard, and you're probably familiar. A lot of standards sit in the
Hmm.
books and never go anywhere. So the next step was a pilot in the Northwest where I got 8 utilities. I had a partner at Bonneville Power Administration that would help with the project, and also BPA provided funding for the project. We got 8 utilities, we got other stakeholders. P&L was doing analysis, and a company called Northwest Energy Efficiency Alliance that specialized in market transformation for energy efficient appliance helped on the market transformation plan. But we ran a pilot with about 300 CTA enabled water heaters,
All
the
right.
largest pilot at the time. And we were able to quantify the benefits of shifting energy. And we did shifting every single day, often twice or 3 times a day.
Oh, really? Hmm.
And we also did customer response to see if they even noticed it. And we discovered, if you want to read the report, that no, they really didn't discover, they didn't notice it. The most important was the economics model that I built at the end. It got peer reviewed, and it showed a benefit cost of 3 to 1 for the idea that if you blanket water heaters with the socket at the factory and you only ship those enabled water heaters to the homes, and then subsequently you start a few years later to run programs where you enroll customers that have those tanks. After the replacement of about a third of the tanks takes place in 5 years, you've got millions of tanks that you can start marketing to. And now it's
Hmm.
time to run the programs. And that was what the cost benefit model showed, was that be hugely beneficial from a cost effectiveness standpoint, and also from the scale, an unheard of scale compared to what we have in the industry today. And
Hmm.
so
Hmm.
that's where, about the time I retired, uh, NIA kept working with the legislatures in Washington. There was an opportunity, and they added it to a bill that was being passed with energy efficiency measures, added it being the requirement to include the CTA interface on all
It
water
was
heaters being.
it was done like not long time ago, is wasn't it?
Well, that the bill got passed, I think, in 2019 or 2020,
Yeah, exactly. Hmm.
and that's when COVID struck. So there were delays in supply chain. So the actual implementation date requirement for all water heaters, I don't think happened until 2022. But
Hmm.
now all water heaters being shipped in Washington and then subsequently Oregon followed
Are
suit,
required, right, to have the port.
are required to have that interface.
Hmm?
And so
So,
literally hundreds of thousands of water heaters get added every year where they're ready to do DR. And
so,
um,
so, so that's really interesting. And those are just two states out of the all of the states in the
yeah, out of
U.S.
50.
Yeah.
California
So
is
it's
considering it, but hasn't passed the
yeah,
law.
but so it's crazy if you think about it. So I'm just thinking about how widely adopted CTA 2045 can be within the US, and do you see this becoming a global standard? Well, it is. Everybody can use it, everywhere. But like, uh, um, uh, how do you think the adaptation in the future may look like, and what are um, uh, the blockers that may stop adapting it further?
So the barriers,
The
just
barriers.
that it solves, are numerous. Doesn't I'll go through them in a moment, but that the question of adoption on wider scale is sort of a separate issue. Um, but one of the keys that is very subtle about the implementation of this standard is that if the manufacturer is going to put the socket on the water heater or any other appliance, it means their engineers have anticipated that these commands interface into their software for the control of their devices, which means you get a very seamless interaction between what the grid wants and what ultimately the customer sees. And it's much less invasive than uh, what you get with the direct control method. And so, because the engineers can perfect the impact on the customers, so it's a very desirable way to do that. So when it talks about the barriers solved, one of them is customer acceptance. You get control with little or no impact on customer lifestyle. Um, Another sort of subtle, if you can get the scale benefit, is standardizing the customer experience. So utilities, there's hundreds of them in the U.S. If they implement demand, they each do it a little bit differently. But with the socket, it's always done the same way. Basically, the customer gets sent a device in the mail, they plug it in, and away they go. So that standard experience as people move about the country means that they're much more receptive to considering it. Um, because there's no labor cost, utility labor cost to install the device, it greatly reduces the cost of the installation. Um,
I do think, can one just buy the EcoPort and install it on his own on the water heater, for example?
um, so generally, not yet. In the marketing plan that I had sort of envisioned for scale, um, eventually they could be in a supermarket checkout line just right next to the bubble gum, and you could
That
pick
would
it
be
up on your
amazing.
way
Yeah,
out and say, "Oh yeah, I wanted to join that
I want to
program."
participate. Yeah.
Yeah, but we're not there yet because there hasn't been enough information sent to customers. There still aren't enough tanks in our area in order to do that approach. But it could be done that way. It could be
Uh
super
huh.
simple. That's and that means just like when you think about a USB memory stick, which has got what trillions of transistors, it's just mind-boggling the complexity of those
Hmm.
devices, even though it's sort of repetitive. But when I was a kid, I remember transistor radios. They used to brag about 4 transistor radios or 8 transistors. It was all about how many transistors you had with the quality. Now, anything that doesn't have a billion transistors in it probably doesn't even count.
Yeah.
So, the complexity you can put into the communication device, the sophistication is cost pennies today. And so that will evolve. And the appliance is future proof for its life, which is 15, 20 years. It never changes. The appliance manufacturer enabled it to be demand responsive. No matter what you do with the communication device in the future, or if it gets changed out 5 times, that device can always do what it was designed to do.
Hmm.
Um, so it also solves a social justice barrier, meaning a lot of times you've got smart appliances coming into the market, but they're the most expensive ones, which are never sold into apartments, and well, maybe upper end, but generally not for most customers. And landlords don't want things installed. So you solve the problem where every tank comes enabled. It means the lower income people can also get it.
Adapt this, and the adaptation rate will be significantly higher because you just
Right.
are. Yeah.
And then it solves a security problem in that if you embed communication into the device, uh, as we've learned, from hackers, one or two devices aren't very interesting to hack. But if you can affect millions or tens of millions of devices, it becomes a much more interesting target. So
Yep.
if you embed communication into the water heater or any other device, it becomes a target for hackers. Whereas with the socket, there's no way for hackers to get inside. They have to go through the communication device. And if there's
Sure.
a, a bug or a problem, a weakness in the communication device, then the worst case is you just take the communication device out and the appliance goes along happily. Or you can upgrade the software over the network like we do commonly today, and now the communication device solves the problem. But so it solves security. Another sort of subtle difference is in the model that most utilities don't really like to use the customer's Wi-Fi network. And the reason being is, while it seems cheaper, customers change their routers, they change their networks, they change the password, and then suddenly the utilities device they were counting on for events no longer works.
Yeah, they're
Then you have
losing
the
ability
cost.
to control. Yeah.
Then you have the cost to go back to the customer and say,
Mm,
"Well, can you help us reconnect?" And they're usually very cooperative, but that cost is not negligible. In fact, I mean, just a single cost can call $10. So if you just get a few percent of these that happen every year, it's cheaper to just cover your own communication. So LTE is likely to be uh, the communication network of choice. So it solves all of those problems, but it doesn't solve the adoption issue.
sure.
Um,
Interesting.
it
So,
was solved with
mhm,
regulation, which is really still the best way to
to
do
force
it.
the adaptation.
But eventually, if we can get success in the Northwest, uh, I call it like when Harry met Sally. There's the scene where the woman says, "I'll have what Sally's having." Do you remember? I don't know if you know that film, but it's a
Yeah.
very cute scene.
Yeah.
And
Well, mhm,
utilities are the same way. They like to be first to be second. Nobody really likes to be first. They like to be second when it's proven. So if there's success in the Northwest, once they see the value of the product, I think there'll be a much higher adoption.
mhm. And
And I should also add the fact that Washington and Oregon require it, and about 10% of the tanks are sold in the Northwest, means all of the water heater manufacturers have engineered their entire product line for CTA-24. They don't sell it in the other areas because it's a little bit extra cost, and every penny counts to them. But it means it could quickly be adopted in those areas.
mhm. So, within those two states, w- how does CTA 2045 work alongside other protocols like OpenADR, for example, to ensure
So it
it's
works. Short answer is incredibly well.
all
Um,
right?
so very familiar with OpenADR. It was sort of co-invented with Lawrence Berkeley Labs back in the 90s someplace.
Hmm.
But it was really aimed at the commercial market, and it was really designed to send demand responsive signals over over the internet. So there's a security issue there. And the commercial customers were all getting used to security issues with people being able to punch through their firewalls. So the security is one of the big benefits of OpenADR. And it's a little bit light purposely on the demand response standards. I mean, it basically standardizes a start command and end command. But the idea was that in a commercial building, that you'd have a very sophisticated device inside the building that would manage devices, and it'd be customized for every building, depending on the things that were available in that building. And so all you really needed was start or stop. So the difference of CTA 2045 is that there's no communication aspect other than the data link layer, which is hugely important. We can go into that later, but um, it focuses on standard commands and specifically for mass market devices so that it's easy for the appliance manufacturers to understand what's being asked of them. And
Hmm.
so that you can actually, and it's been tested and done, you can send the CTA 2045 commands as a payload, content payload in the OpenADR protocol.
Right.
So you get perhaps the advantage of both worlds. You get the security
Hmm.
over, say, an internet link, and it's embedded uh, in a communication device, which is OpenADR standardized on the WAN side, and then on the appliance side, it's CTA 2045. And so they're totally compatible, um, and they can exist without each other. But it's a little bit unusual to embed in a device, a mass market device, the OpenADR certification because of the standardization and the trying to remember the certificate that the device has to get in order to be OpenADR compliant. So that's a little costly and awkward, but not so with CTA 2045.
Hmm. So you mentioned again that the HVAC and water heaters. Are you aware, especially within those two states, any other cross industries adaptation of CTA 2045? And just really wanted to explore the adaptation applications. And
Right. So in the days when the standard had been defined and spec'd out in 2013, EPRI was very involved with utilities and manufacturers. And at that time, they did prototype demonstrations with the manufacturers. And at that time, they did EV chargers, they did pool pumps, they did thermostats, and not much has come of those. And even in the HVAC world, it's sort of minimally used. Mitsubishi has been one of the people that has their devices compatible with CTA 2045. Um, but it's mainly the water heaters so far.
So my actually my next question would be, what role do manufacturers play in supporting the CTA 2045, and how it's important in terms of their engagement and involvement in this adaptation? I guess it's significant, right? Because
Yes,
if they would agree to basically onboard this actually a socket into those devices, it will make the world the demand response work like way better from the CTA 2045 standpoint, right?
right. It's just um, it, it's and it's an essential requirement that they be involved early on. And as I've already mentioned, you actually get a huge advantage because their engineers know exactly how to modify their devices to minimize the customer impact. So that's all a big plus. There are other big pluses potentially. Right now, a lot of smart appliance manufacturers, and let's include smart thermostats, um, typically use Wi-Fi, and you go through to their cloud.
Hmm.
In fact, there's a lot of utility programs that use smart thermostats, but you access the resource by going to the manufacturer's cloud. And that actually turns out to be very expensive for utilities because A, it's not standardized when you have to go to their cloud. And if you think about how many appliances and manufacturers there are, it could be like 40 separate manufacturers. And we're not talking small companies. Carrier is huge, or
Yep.
Nest, Google. I mean, these aren't small companies, they are international. And once they do it their way, they expect utilities to follow suit. So it becomes expensive. You got to get the lawyers involved in protecting everybody. And the manufacturers can change it a whim. So there is another sort of subtle benefit that could come when we get to scale, which is that the manufacturer are a little bit worried if the utilities have direct access to their devices, that they're going to interfere in a bad way with their devices. And conversely, the utilities really are a little bit worried about the OEMs and not getting enough data and so forth. So the socket ultimately allows absolutely equal access. There's no reason that if you have the socket and an appropriately configured communication device, that both the manufacturer and the utility could have equal unfettered access. And they would both get everything they want. So the manufacturers get all the data they need for improving their product. Utilities would get the data to validate their events, and these OEMs could monitor the control and make sure that bad things aren't happening. It could be a very synergistic cooperative device with a single um, communication device. It could be actually a shared resource if there was a third party that would be autonomous. There's actually a startup company I'm working on with my partner, Lance
Hmm.
Ahern, that would do exactly that. A third party like us would only focus on the communication link and equal access to the utilities and manufacturers.
Hmm.
And then both get everything they want with just one reliable communication device.
Mm.
But you got to have the OEMs, and right now there's no benefit for them to enable remote communication by utilities because it just adds, even if it's pennies, it adds cost.
Sure.
And they're in a mass market, and pennies are important to manage.
I completely agree with you. That's why I'm just really curious. It is being said that when California implements a certain rule, especially when it comes to energy, then it goes wider and wider in terms of the adaptation in the US. So that might be actually a good path forward, because if the legislation
Absolutely.
will, yeah, if the legislation will enforce this, it will be definitely a significant uh, push for the wider adaptation. Um, I got two more questions. As the grid evolves, what's next for the CTA 2045? Like, do you think it should be solely focused, on the water heaters? As you mentioned, there are like different type of the tries in terms like EV chargers and HVACs and things like that. Should it be focused only for water heaters, or or do you believe any other like wider spread of the adaptation in terms of a different device classes?
I've got lots of opinion on that. um, so if you could jump ahead, if you had smart appliances out there, meaning they can hear and understand signals, then most regulators would like to be sending what we call prices to devices, meaning instead of doing control commands, you send prices to the device and hopefully like an entire day's worth of information so the appliance can determine the best time to start the cycle, end the cycle, etc. And with renewables, it can be different every day. It's not always standard like a time of use response. But that's a chicken and egg problem. So regulators really can't do prices of devices until most customers can benefit from that approach. And you know, so even though CTA already has everything baked into the standard to support prices of devices, so it will support direct control commands or it supports price-based approaches. But again, it becomes back to um, getting wider adoption. And as wider and wider adoption happens, then the opportunities to do more with the standard just grow and grow. I can't. Did I answer the question?
Yeah, I believe so. Yes. Thank you for that. And the last one, and again, we've been talking a little bit more in terms of the customer, standpoint. Uh, how does the CTA 2045 make adopting the smart energy efficient appliances easier? Again, from the customer standpoint.
Um, well, I already mentioned standardized customer experience, so it
Yep.
would be ultimately the same across utilities how they adopt. But there's some features in the later revision of the standard um, that has what I call the more comfort, more savings slider. So, in working with the early manufacturers, they were very concerned about getting um, overly responsive appliances because that would mean less hot water available at
Hmm.
people's tanks. So they would only implement, rightly so, very conservative designs. But if you let this evolve and you have customers that can, and there's incentive for programs from utilities that give customers incentives for more response, then the slider allows the customer to choose essentially a nearly hands-off response, except for emergencies, all the way to, use my device to the maximal extent. And that option, that interface, is already baked into the standard. As far as I know, it hasn't been implemented anywhere.
Hmm.
But that experience would hugely benefit customers at the the ideal sort of interaction between the appliance because it's been engineered that way by the manufacturer, and it would
Hmm.
also allow much more response for the grid.
Hmm.
So, what other benefits?
Security you mentioned as well, right?
Security. There's another which is subtle, and utilities really wouldn't want to hear this, but ultimately, over time, the models for in-home energy management are going to change. And right now, it's sort of device by device. But the ultimate dream is that you have an in-home energy manager, particularly if people have solar, battery backup, or uh, and you want to maximize the solar battery systems across devices and prioritize them. So ultimately, you'd really
Yep.
want uh, all the devices to listen to your in-home energy manager, which would be smart enough to optimize across devices. And the beauty again of CTA 2045 is that, well, if you've been using a utility-based communication device, but now you want it to work with your in-home energy manager, you
It
just
can be
go
easily
unplug
switched.
the device
Yeah.
and you switch the device and you have a new model.
Yep.
And it's it's super simple, and they can be instructed to do that. The new communication devices could come equipped with the energy management system. So it again, that's baked into the approach. Um, it's not. We're so primitive in terms of what is happening in terms of energy management. That's not even really on the radar screen yet, but it's there waiting.
And in terms of, again, I'm referring to the two states that CTA 2045 has been mandated, and there is a wider adoption of those. What are the financial benefits for the end user? Like, is there financial initiatives
There are. That's entirely up to really the
for the
utility.
utilities, right?
Um, but in every case, there can't really be really big financial incentives because one device by itself just doesn't make that much difference. It's in the
Sure.
aggregate that it really makes. So, yes, there can be incentives. There can be soft benefits like recognition and so forth. But that's really into the utility design. That traditionally with demand response programs, there's been incentives for HVAC up to about $50 a season for letting the device be cooperative.
With the
So that's
utilities.
sort of the
Yep.
upside. What I really hope, in my view of a sustainable future, as we get to more and more uh, in the U.S. at least, 20, 30 years ago, there was no recycling of garbage and yard debris and such. You just put everything into the trash can. And
Yep.
now jump forward 30 people, I don't think grudgingly, I think they feel, most people, that it's a good thing for the environment that they recycle. They put the yard debris into one thing and they put
Gotcha. Yeah.
the glass and recyclables into another. And I think a lot of people feel good about that they're trying to do their best to minimize waste. And in much the same way, I think the largest benefit when we get to scale is going to be that, I'm reducing the carbon footprint of my appliance. I know it's going to use more renewable energy, uh, and it's helping to reduce the cost of the grid. And I'm really hoping when we get to scale that that becomes the primary benefit. And
Oh,
in the
that
pilot that I mentioned,
mhm.
we asked about environmental benefits, and these were self-selected people, so it's hard to say. And it's the Northwest where we're all green, but environmental benefits was important to them as a benefit.
Yeah. Well, that's a really great I would say summary of the benefits and also the wider let's say social impact that we can actually all make for the while adopting CTA 2045. Conrad, thank you for the insightful discussions. I believe we've covered a lot from the standards origins to industry adaptation, and also when it comes to the impact on the customer grid, as we've spoken at the very end. Before we wrap up, is there anything you'd like to leave us with? A thought on where you can see the energy sector heading, or advice for that working to implement on CTA 2045 or similar standards? It will be really interesting to hear from you.
Um, I'm trying to think of. I mean, there's. I think. I've done a lot of analysis on the end state when we get to 100% renewables, and we're still decades away from that, at least two. Um, but in those end states, the amount of battery storage you're going to need on the grid is tremendous. I mean, we don't even have 1% of what we need, and there have been some pretty big projects built, and you have to get through this thing I call the windless night. And so, in that end state where you have so many batteries, and actually there's going to be a lot more batteries in homes. I even hope that someday builders add battery back up to the home just for outages, but also to help the grid and let the grid control the battery for optimal use. Um, those future energy management systems will happen. It's at least a decade away, but their ability to use the CTA interface and be able to optimize, what happens in the home, both to minimize the use of fossil fuel when there's no wind or solar, and also to maximize use when there's excess wind and solar, is going to be a really, really important. And it's not going to get rid of batteries, but if you can displace 10%, 20%, 30% of them, you've saved the grid a lot of money, and it's huge social benefit. So that's where I look in the long run.
All right. Thank you very much. Lovely speaking with you. Thank you for your time. Yeah, we really do appreciate. I'll put links to Conrad's profile down there below the video. It's going to be published on YouTube and obviously on LinkedIn as well. So, Conrad, thank you very much for the insightful discussion. Yeah, and very much looking forward to see the next steps on the standard adoptions, development, and fingers crossed for the next initiatives that you're part of. So thank you very much, and thank you audience as well, and talk to you soon.
Thanks, Bart.
Thank you.